morning. Today I want to do inequalities, which is a little more complicated than equalities. Inequalities lead to inequations, which have tremendous uses in all sorts of fields, including optimization. For example, when you are trying to maximize your happiness subject to an income level, then you are dealing with a world of inequalities because you are trying to get more happiness than any other combination of consumption can give you. Similarly, when a company tries to produce the maximum using the same inputs, it is again dealing with inequality. What I want to do now is do a little bit of an experiment to show you the power with which mathematics has uses in all sorts of different fields. Now, what I'm going to show you is money, different denominations. I am not involved in playing Monopoly here or Russian roulette. What I have is a bunch of 10 rupee notes here, 100 rupee notes here, 500 rupee notes here, and 1000 rupee notes here. Now I'm going to ask you a simple question. I'm giving you a choice. You have the option of picking up 4 of one kind, 3 notes of a second kind, 2 notes of a third kind, and 1 note of a fourth kind. Again, you have to choose 4, 3, 2, 1. Where I give you the choice of is what kind of notes you choose. Alright? For instance, you may choose 4 of the 10 rupee notes and 3 of the 100 rupee notes, or vice versa, or any other combination. Now, I'm giving you this choice. Please pick up the notes depending on whatever you feel like achieving. Now, to most people, since I seem to be giving away money for free, you will come up with the obvious strategy. That is, you'll pick up 4 of the 1000 rupee notes to pick up 4000. Then you'll pick up 3 of the 500 rupee notes, which is 1500. Then, so you have 5500. Now with 200s it becomes 5700. And then you have 10. So 5710 is your total booty. Now suppose there were a different kind of people, the Mother Teresa type, and I gave them the same choice. Now they are not like us. So if they were given a choice, but at the same time forced to make one choice, that they have to pick up 4, 3, 2, 1. What is their choice? But whether is not their choice. In which case somebody like that would obviously pick up 1 of the 1000 rupee note, 2 500s, so she has picked up 2000 now, then another 300, 2300, and then 40 here. So 2340 is what she has got. Now, what I am referring to is the greedy algorithm, which is also known as the rearrangement inequality. Again, rearrangement inequality or the greedy algorithm. The name greedy algorithm is obvious. Okay, why rearrangement? I will show you. What this experiment should tell you is that it can be generalized, surprisingly, to say that whenever you have 2 sequences, those of you who are well versed in mathematics will know what I'm talking about, which are ordered similarly, that means either in the ascending order or both in the descending order, then we say they are similarly ordered. However, if one is ascending and the other one is descending, then it is said to be sorted oppositely. So Mother Teresa sorted oppositely because she picked up the highest denomination, 1000 rupee note, only 1 of them. Whereas the normal greedy person did it the other way around. So now let's see how we can apply it to different branches in mathematics. For example, if I asked you to find the minimum value of this expression we see here, cos cube x by sin x plus sin cube x by cos x in the first quadrant, which is why x is between 0 to pi by 2 here. Now the maximum value is obvious because you can keep increasing it by making either sin x or cos x close to 0. So there is no maximum here. So what is the minimum we can get? Now let us think of cos cube x and sin cube x as one sequence. And if cos cube x and sin cube x is one sequence, which means cos x and sin x also will be sorted similarly. Suppose cos x is greater than sin x. Then for example cos 0 is greater than sin 0 at that level of x. If cos x is greater than sin x, cos cube x is also greater than sin cube x. A discerning student will know why I am making it the first quadrant, because both are positive there. If cos x is greater than sin x and cos cube x is greater than sin cube x, then it will mean that 1 by cos x will be less than 1 by sin x, because here we are taking reciprocal, so it becomes opposite. In other words, these two sequences, cos cube x, sin cube x, and the other sequence 1 by cos x, 1 by sin x, are sorted oppositely, which is our Mother Teresa. So therefore we know this has to be the minimum. In other words, this will give rise to this sign. This combination will be less than equal to any other combination. And if I look at this sequence, cos cube x, sin cube x, along with the second sequence, now 1 by sin x and 1 by cos x. Now remember, cos cube x is greater than sin cube x because cos x is greater than sin x. If cos x is greater than sin x, 1 by cos x is less. Therefore 1 by sin x is greater than 1 by cos x. So these two sequences now are sorted similarly. And so therefore that will be the maximum. So in other words, we have that this is less than equal to that. So therefore, and when I'm sorting like this, what did we do there? To count my total amount of money, I multiplied 1000 by 4, etc. Similarly, I will multiply the first one here, cos cube x, by the first term in the second sequence. So cos cube x times 1 by cos x is cos square x. And remember, as with money, we are going to add up now. Plus sin cube x times 1 by sin x, which is sin square x. I have this less than equal to cos cube x by sin x plus sin cube x by cos x, which is what I asked you to do, because cos square x plus sin square x is a well-known identity. We know it is always equal to 1. Therefore, we have concluded that our original expression has a minimum value of